Hello everyone, let's discuss another Leetcode problem. Today's problem is longest common subsequence. So given two strings, text1 and text2, we have to return the length of the longest common subsequence. If there is no common subsequence, then we have to return 0. Okay, so the definition of a subsequence of a string is a new string generated from an original string with some characters without changing the relative order of the remaining characters. Say if you have, say, A, B, C, D, E, if this is your string, then one subsequence might be B, C, E, okay? Or another subsequence might be A, B, D, E. That is also a valid subsequence. But if you say like B, E, D, well, that is not a valid subsequence because you see the orders are not maintained. So B is here, then D is here. So you cannot bring E in front of D. So that is the definition of the subsequence. Now we're given two strings and we have to find the longest common subsequence between them. So let's say the first string in the example one is A, B, C, D, E. And the second string is ACE. So you see ACE is also present in the first string. So obviously AC is the longest common subsequence, and the result is going to be 3, right? The length is 3. But the second example, you see both the strings are ABC. And obviously the longest common subsequence is like they totally match. So it's going to be 3. For the third one, first string is ABC, the second string is DEF. And you see there is no match between these two. That means it's empty. There is no common subsequence. So the result is going to be 0. Okay, so how can we solve this problem? Well, let's think a little bit about this. We can start with the naive way. So the naive way is trying to find all the subsequence in both the strings and match with each other. So if we have, say, A, B, C, D, E, what are all the subsequences here? We can think each of these characters as a bit. So, and say the bits are like 0 and 1. So 0 means that we won't consider that character, and 1 means we consider that character. So for each character, there are two choices. Either I include it in the subsequence or I don't include it. So for example, this subsequence is DE, okay? And then we decide to include the first one, we decide to include the second one, then we exclude the third one, include the fourth one, and exclude the fifth one. So this is going to be A, B, D, right? This is the subsequence. I'm talking in terms of bit because it makes things easier to understand that how many subsequences we can build. Okay, so how many choices we have for each character? We have 2 choices for each character, right? So in total, then it's 2 to the power 5. Like there will be like 32 subsequences. Okay, so 2 to the power 5 goes to 32. Okay, so can we say that if the first string has a length of m, and the second string has a length of, like, it can be any string, right? For now, m is 5, n is 3. It has a length of n. So how many subsequences we have? So the number of subsequences is going to be 2 to the power m, and this is 2 to the power n, right? So we have to compare these 2 to the power m subsequences with 2 to the power n subsequences. So in total, it would be like 2 to the power m into 2 to the power n comparisons, right? Just it. So that's going to be 2 to the power m plus n. Do you see how big this is? This is an exponential algorithm if we do it in brute force way. And that's not all, because once we are actually comparing two subsequences, say this with this, right? So if this subsequence has a length of say m and this has n, so each comparison is also going to have like m into n comparisons, right? So that would be also added here. So it's like an exponential algorithm. So we already understand that that is not the way to be, right? So let's see if we can break it down into smaller subproblems and recursively solve it. Okay, so let's break the problem down to a little bit more details. Say string x is a, b, c, d, e, and string y is a, c, e. So we want to find the longest common subsequence between x and y. Say the indices of x run from I to m, and where m is the length of the string. So this is in index. So this is index I, and this is index m, and where this is index j and this is index n. Okay. So as you see here, there is a match between the first two between the characters of index I and index j. So in that case, can we say that we can count 1 plus? Now this problem can be reduced to, say, if I just don't, like, if we leave this, can we say that this problem is now can be solved with a smaller problem? We just want to find the longest common subsequence of x starting from I plus 1 to m, and y starting from j plus 1 to n. Okay. So if I find the longest common subsequence between b, c, d, e, and c, e, and add 1 to it, so this is when if xi equals to yj, if the character matches, right? Now think about another example, but the characters don't match. Say it was b here. If it was b there, in that case, can I say, so since there is a mismatch between these two characters, right? There's a mismatch. Can we say that, okay, let's leave a from the first and try to, so this same thing is now is going to be, we will try it in a new way because these first two characters don't match. We will take x, the whole of it, and y from, we'll take y from j plus 1 up to n, right? This is one option, or we can try this, right? So we can just take the whole of the second one. That means LCS of x starting from I plus 1 to m and j to n. Okay. And we want the max out of these two. So because, so out of these two, I want the max. And this is if xi not equals to yj. So do you see that we have now defined the problem using subproblems of the same type, right? So we have defined it recursively. So let's try to log this thing in a using a table, a 2D table, which is very common. Okay, so the characters are like A, C, E, and this is A, B, C, D, E. Okay. So So for any recursive problem, we are trying to solve this recursive problem using dynamic programming, because already we have mentioned that if we use brute force, it's going to be an exponential, right? Okay, so each of these cells will represent, so this cell, say, take any cell, say this cell is going to represent the LCS value of, you see, this is E and this is C, right? So it will represent the LCS value between ABC and ACE. Okay. So that means to get the LCS value of A, B, C, D, E, and AC, I need my final value here. That is my target. Okay. Next, as a base case, let's say we take the empty string. So empty string, the LCS between an empty string and any string is 0, right? There is no common subsequence. Similarly, the LCS between this empty string and ACE, like A0, AC0, and also ACE0. Okay. Now, look at this. Say, let's start focus on one cell. So let's focus on this cell. Okay. So this one, you see the characters match. C and C match, right? And this this cell represents LCS of ABC, ABC and AC, right? And the characters match. So can I say that this is like 1 plus LCS of AB and A? Can I say that? Yes, right? Since the characters match. So what is this? Let's try to find out what is the cell for this. You see the cell for this is this one, right? So if a character matches, we just can go diagonally up by one place and add 1, right? Okay. So there goes the about the matching character. Now let's look at another one. Say here, let's look at this one where there is no match. So this location. Yeah, so this is LCS of ABC and ACE, right? And you see that C and E don't match. So C and E don't match. So there is no match between C and E. Can I write it as LCS of, say, AB and AC, sorry, AB and ACE, and or LCS of ABC and AC, and take the max out of it? Okay, so let's identify the cells for these two. Okay, so LCS of AB and AC is going to be here and here, right? So this is the cell for this. And the other one is LCS of ABC and AC. So ABC is here and AC is here, right? So this is this. Okay, so that means if there is a mismatch of characters, we either go to the top or go to the left. Go to the top and go to the left. So we defined this whole thing using a, so this is the bottom-up approach, right? So we define the whole thing using a 2D table. If there is a character match, between 2, we just go diagonally up and add 1 to it. And if there is a character mismatch, we go up, we go to the left, take the max. And our final destination is to find these cell, right? That will give me the LCS of ACE and ABCE. Okay, so let's try to fill this up. So initially, we have our base case with all the, say, with all the, okay, so the empty string has a subsequence of longest common subsequence of 0 with any other string, right? So we filled up the first row and the first column with zeros, and then you see A and A match, so we add 1 to the diagonal. AC don't match, we take the max from the left and top. Here no match, so max of left and top. No match, 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 max of left and top. Match, so add 1 to the diagonal. No match, okay, so this was also 1. No match, so max of left and top. No match, no match, no match. No match, oh sorry, here I have made the mistake. So if there is no match, I have to take the max of left and top, okay? No match, and then no match again. And now if there is a match between E and D, so go to the diagonal and add 1. Okay, so finally, this is my result, 3. 3 is my result. So what is the time complexity of this algorithm? If this length is M and this is N, okay, so we had to calculate M into N values. So the time complexity is order of Mn. Space complexity, you see the table has Mn space. So we have to use this extra Mn space, and that is fine. Can we optimize this space even further? That's a clever way to do this. You need a little bit of observation. So let's see, when you are actually calculating this, right? We were just depending on this portion, right? This previous row and the left. And that's true even for other rows. So when I am calculating any row, I am just using the previous row. So can we do this? Can we just eliminate, say, eliminate all other rows and just keep 2? And we'll just take the smaller text on the top so that I can use even further, lesser, right? Okay, so what I do first is I'm going to, okay, so I will take the smaller text on the top and I'm going to fill the first row with 0 and this left with 0. And then I will just do the same thing that I was doing. There was a match, no match, no match. Okay, done. Next, what I do is when I am doing it, so mimicking that I am doing it for B, right? So basically I'll be doing this one, but using the same space. So what can I do is I can just copy the second row to the first row. And now instead of A, B is going to be calculated, right? It's going to be 1, 1, 1, right? Okay, next I copy the second row to the first row and calculate C here. And you see 1, 2, 2. Next I copy 1, 2, 2 to the top and calculate what? D, right? Calculate for D. So it's going to 1, 1, 1. Sorry, 1, 2, 2. Next, I copy is the same, and now I am going to do it for E. For E is going to be 1, 2, and 3, right? And finally, I just do the same thing. Finally, my result is 3, right? So I can just copy it here. 1, 2, 3, and return this. So the space complexity now becomes order of minimum of M and N, because we use just 2n spaces. We did still the time complexity remains the same because we had made order of mn calculations, but the space that we have just used 2 rows of size n, which is the smaller of the 2 texts. Let's code this. So initially we'll code it just simply using a 2D matrix in the bottom-up approach. So for that, we need this 2D matrix. Let's call this LCS. And the size is going to be add 1 for that empty string. Okay. And then we fill the first row and the first column with zeros for the empty string, if you remember. So there goes the first row. Sorry, first column. Let's do this for the first row as well. Okay, so this is our base cases. Now we want to calculate each of the cells, right? Okay, so this one is going to be text 2. Okay, so for each of the cells, we have to check the character. As you see that we are matching the character index with the character itself. Like the first character is actually has the index of 0, right? So that's why we are, okay, so we have to start from the first character, but the index is going to be 1 minus 1, 0. We're starting from 1 because the 0th index is, we assigned it for the empty string, right? Okay. So if this one matches with the character from the text 2 at j minus 1th index, then we just assign LCS ij to be 1 plus LCS of I minus 1, j minus 1. Else, LCS of ij equals to the max of LCS of I minus 1, j, and LCS of I, j minus 1. Finally, after we fill the whole board up, we return LCS of this, right? Not exactly this, because this is the length of the array, but the indices are going to be 1 less. Okay, so let's try to run this. There might be some typos. Yeah. So this is, you see, this has to be J. Okay, so got accepted and then we submit. Yep. So this is order of, the space complexity that we used is order of MN. Okay, so to optimize it a little bit, we want to use 2 rows and columns. So we are assuming, okay, so we want to put the smaller columns on the top. So we are assuming that text2 has the smaller number of is smaller than text1, right? Has lesser length. But what if text1 is actually smaller? So in that case, we have to check. What we can do is, if that is the case, we can just make a swap. The mistake here. So now the smaller one is in text2, okay? And then I defined my array, 2D array of 2 rows, and number of columns is number of columns, okay? And then what I do is, so I have to fill up the first row with zeros, and then I also have to fill up assign 0 to the first element of the second row. That is also 0, right? As you have seen in the example. Okay, so then I have to run this loop. This should remain just the same, but just it will check again as the previous row, right? And it will just check again is the previous row or the current row is the second row. And finally, okay, so after I do this 2 things, next what I have to do is I have to make a swap. Say int temp goes to the first row, assign the second row to the first row, and finally I return the last element of the first row. Okay, so a few other mistakes. I had to put like 1 because so a few other mistakes I had to put like 1. This is the second row I'm filling up, okay? So I submit it. And this is much more faster. You see that. Okay, thanks for watching.